Hi there, everybody. This is your homework helper for Lesson 1, Module 2. What we're talking about today is the distributive and associative properties when using that to multiply whole numbers by powers of 10. What does that mean? It means if we have something like this, 40 times 50, we can take the 4 times the 5 to get 20 and tack on the 2 zeros and have a product. We have ourselves a nice little product there, but what we don't have is necessarily an understanding of what the heck just happened behind the scenes on all that thing. And just like math, just like anything else in math here, it's not necessarily understanding rules or memorization, but it's understanding the processes and understanding the why behind it. So we're just going to go through that real quick. So follow along with me. If I start off with just a simple multiplication problem like 4 times 30, and I could say here, I could rewrite this. I could say I have 4 ones, and I'm going to multiply that by 3 tens. Okay, and so I could do that. I could do my 4 times 3 would be 12, and my ones times my tens. Well, 1 times 10. Multiply that. Sorry. 1 times 10 would be 10. So I have my 12 times 10, my 12 from my 4 times 3, and my 10 from my 1 times 10. So I could do that to get 120. And if I go ahead and look at this, yeah, if I do multiply 4 times 3, that's 12. And I can tack my 0 on there, so I can see how that works out. If I do 40 times 30 and do the same thing, I can say instead of 4 ones, I can say I have 4 tens. And I'm multiplying that by 3 tens, and I'm going to get 4. I'm going to get 12, and what am I going to have? I'm going to have 12 whats? Well, I have tens times tens now. I have 10 times 10, and 10 times 10 is 100, so I'm going to have 12 hundreds, right? And 12 hundreds, that's 1200, 1200. If I say I can have 40 times 300, well, same thing. I got 4 tens, and I'm multiplying that by 3 hundreds. And well, I have my 4 times my 3, like I know, is 12. But what's my 10 times my hundreds? If I have 10 hundreds, if I didn't know I could count by hundreds, 1, 2, 3, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So I have 12 thousands, and 12 thousands is 12,000. So I could do this all the way up to 4,000 times 30. I could keep going, and it would be the same type of a thing, where we really are splitting off my 4 and my 3, and I want you to understand then what the unit behind all of that is and what it stands for. When we do this, I could go ahead and instead of saying this here, 4 tens and 3 tens, I could rename that. I could say 4 times 10, right? Because that would be 4 tens. And I could say 3 tens would be 3 times 10. And so this would be another way I could say this. These are the same things, right? 4 tens and 3 tens, and this is 4 tens and 3 tens. And so so we can use these numbers instead of writing the units down. Instead of using unit form, we can just do standard form and work this out as a problem. So let's go ahead and let's take another step. Let's go 6. Yeah, we're changing colors here. We're getting fancy. 6 times 5. Excuse me. If I take a look at this and I say, and I have 6 times 10 plus 5, or times 5, excuse me, which is what this is, right? 60 is 6 times 10, and I want to multiply by 5, or 6 times 5, and I multiply by 10. Do I get this? Do I end up with the same products here? Let's work it out. 6 times 10 would be 60. No, thank you. 6 times 10 would be 60. 60 times 5 would be 300. Or 6 times 5 is 30. Times 10 would be 300. So these are both the same. Just because we change the order of the factors doesn't mean we change the product. And we can change the order of our factors. And when we go about changing the order of the factors and putting them differently, when we group them differently, we call this our associative property. So let's go ahead then. Let's take a look at this as 60 times 50. All right. When we do 60 times 50, you could think of it as, you could think of it as 6 times 10, and then you could think of this as 5 times 10, right? I could also rearrange the factors. I could rearrange them, group them differently, and say, well, it's really 6 times 5, right? 6 times 5, and I have my 10 times 10, and I can really write that 6 times 5 times, well, 10 times 10 is 100, in order to find my product. 6 times 5 is 30, and 30 times 100 is 3,000. What I'm doing here is, rather than taking my 6 and splitting it out and saying 6 times 10, and then 50 up here, well, 5 times 10, I'm kind of taking a shortcut. I'm kind of skipping that and saying, well, I could just do 6 times 5. It's the same thing, and then do my, if I took care of that, well, I still, I have a 10, so 10 times 10, that's left over, and that's my 100 here, and then I'm still getting my same product, but I'm making it a little more manageable, a little easier for me to see. So let's try this one. 60 times 500. Do the same thing. I'm going to focus on my 6 times my 5. I could do 60. Sorry, not 60. Excuse me. I could do 6 times 10 times 5 times 100. I could do that, but it's definitely easier for me just to do 6 times 5, because that gives me a product that I can find easily. 10 times 100. 10 times 100 would be 1,000. 10 hundredths. I like to write it this way. 10 times 100, and then like I said, 10 times 100 becomes 1,000, and so then I'm just left with 6 times 5 times 1,000, 30 times 1,000. There you go. Or 30,000. When you're using this property, when you're doing this, you're making it a little bit easier on yourself, because, let's say you have something like, what could I give you? Let's say you had this. Let's say somewhere you saw this. It was 6 times. Let's do 5,000. And you could go 0, 0, 0. This is actually, it's relatively simple to do this in the standard algorithm. But let's say you wanted to try something different. Let's say you didn't understand that. Let's say you need to show it in a different way. Or let's say you had a more complex number. Doing this associative property helps you visualize moving things out, shaking things out, place value times place value, and what that all means. So then, finally, on top of all this, we have our distributive property. Where we have something like 451 times 8. And when we do the distributive property, we really want to kind of bounce the 8 multiplied by each one of these, right? 8 times 1, we have that. I also have 8 times this 5, but this 5 is not just 5. 8 times 5, it's actually 8 times, well, the 5 represents a 550, right? 8 times 50. and the 4 here represents 400. So 8 times 400. And then I'm going to add all those up. And that's difference distributive. You're taking them one at a time, and then you're adding them all up to get your answer. 8 times 5 is 40. 400. 8 times 4 is 32. 3200. And then I would add those up. 32 and 4 is 36. And I have that 8. When this relates to the homework, which I know many of you are here to look for the homework and have a homework helper. As it relates to your homework, really, what you're looking at here is the same kind of a thing. I have 43 times 30, and this is saying, hey, use your knowledge of place value units and basic facts to fill this out. I have 43 ones, and I have 3 tens. And I have my 43 times 3. What do you know about your basic facts? 40. If I have 4, I have 8, and then I have 12, so that would be 120, right? And I have 3, 3, and 3, which is 9. 129 tens. Or 129 tens. I have the same thing here. What they're basically saying is, hey, can you split these things out? What is this? What does this represent? 43. It's 43 what's? It's 43 tens. And this is 3 tens. And 10 times 10, well, that equals my hundreds, right? So now I'm just really focused on that. And it's ultimately doing the same type of process that we were doing here. And that's why, you know, it gets down to you. So don't let yourself get distracted by this. I know sometimes my students, these kinds of things are tricky because I think that they're not understanding what to put in these blanks. But check it out. You have tens. It's asking you to put the tens in here. And then here it's asking you to find the product. Here you have hundreds, and then the same thing. Find the product. How many hundreds? Here it's giving you the number, but it's not telling you what the unit is. So what's 10 times tens? And what would go there, right? And then if I were to go further down, determine if these equations are true or false. Defend your answer using your knowledge of those of place value and the commutative, associative, and or distributive properties. Saying do what you need to do to solve these problems. So anyways, I've rambled on long enough, and hopefully I haven't confused you more than I've helped you. Of course, you can always post questions. You can always bring your questions to class. You can always Google somebody else who might be able to explain it better to you. Certainly, just because I am a teacher doesn't mean I'm the end-all be-all of teaching. So, you know, don't ever give up. Don't ever say you can't, because you're wrong. You can. You need to work at it. So I believe in you. Work hard, do your best, and I'll see you later.